Hello, welcome to Q in Motion's course on understanding electricity and electronic devices. In this video, we're going to talk about current sources. Why would we want to study current sources? Well, there are some devices that can work as current sources, right? And to understand them, how they work and how they behave in electronic circuits, it is very helpful to understand how a current source works and behaves in an electronic circuit. Some of these devices are inductors. So inductors can store energy in the form of a magnetic field and then release it in the form of a current, right? And another application for current sources is transistors. Transistors can work as current sources in some circuits, okay? Before we get into the details of current sources, let's go back a little bit and review what we studied with power, right? At the time when we studied electrical power, we defined power as a product of the voltage times the current flowing through a device, okay? Now, a device could be delivering power to a circuit, like a power supply, as a voltage source, or it could be consuming power, like a resistor, for instance. When current in a device flows from positive to negative, the device is consuming power, okay? So in this example, we have current flowing from the positive to the negative terminal. And if you think a little bit, this is typical for a resistor. In a resistor, you have one terminal that's going to be more positive than the other one, and current's going to flow always from the more positive to the more negative terminal. In the opposite case, when current in a device flows from the negative side to the positive side, the device is supplying power to the circuit, right? It would be something like this: negative here, positive here, and current flowing this way. And the typical case where this happens is on a voltage source, right? On a voltage source, we have a negative and a positive terminal, and current flows in this direction, like from the negative to the positive terminal inside the power source. Actually, it will flow outside the voltage source from the positive to the negative, right? So in many circuits, you would have this terminal on the voltage source connected to this terminal on the resistor, and this terminal on the voltage source connected to this one on the resistor. So current will flow in this direction, in this loop, right? So from positive to negative on the resistor, and from negative to positive in the voltage source. Okay, keep this in mind because we're going to use it in a few slides when we study current sources. And that brings us to the core topic of this video, which is current sources. A current source is a device that will force a set current through a branch in a circuit. This would be pretty much the simplest circuit that we can have with the current source, right? On previous classes, we dealt with voltage sources here, right? A positive side and a negative side, and whatever voltage the voltage source was. Now, here we have something, this symbol here is the symbol for a current source, and the value is 10 milliamps. So this current source is pushing 10 milliamps through this circuit, like this. So if we wanted to know what the voltage is at point A here, we would notice that the other end of the resistor is connected to ground, so that's our reference, 0 volts. And applying Ohm's law, 10 milliamps times 1 kilo ohm, that would put this terminal at 10 volts, right? Mathematically, it would be like this. This is just applying Ohm's law to this circuit, right? Only on previous circuits, we would normally have information about the voltage of this thing, of this source, but now we have information about the current, okay? If this was a 10-volt voltage source, the voltage at point A would be 10 volts independent on the resistor. But this is not the same thing. This is a source that is pushing 10 milliamps through this circuit. So the voltage here is 10 volts. But if this resistor were to be 2 kilo ohms instead of 1 kilo ohm, the voltage here would be 20 volts, okay? 10 milliamps times 2 kilo ohms, that would be 20 volts, okay? Sounds weird, right? It's a bit counterintuitive, and we'll see in a minute why it's that. So the question is, can you purchase a current source? And not normally. We have voltage sources all around us, right? Battery is a voltage source. Cell phone charger is a voltage source. The 120 volt outlet is a voltage source. And we're surrounded by voltage sources. So the concept of a current source is not very intuitive because we're simply not used at all to deal with those, right? Now in recent years, when LEDs are being used for lighting, some LED lighting controllers work as current sources. If you remember from our class on LEDs, LEDs have a voltage drop that is fairly constant, about, we said maybe 1.8 volts for a red LED, and it goes higher for green and even higher for blue. And blue and white may have around the same voltage drop through them. And the brightness is not really controlled by the voltage, but controlled by the current. So devices that control LED lighting work as current source, and they will push a certain amount of current through an LED or through a string of LEDs to control the brightness, okay? Very good. Now let's try to understand a little bit more about how these work, okay? The previous circuit was fairly easy, right? Just a current source and a resistor. Let's try to mix it up with some voltage sources here. Here we have a voltage source of 12 volts, a 1 kilo ohm resistor, and a 5 milliamps current source. And we want to know what the voltages, the points A and B are. Remember, this one is ground, so this is our 0 volts, okay? So the voltage at point A is easy. It's just 12 volts because this is 0 and this voltage source is forcing the voltage of terminal A at 12 volts, right? Now, what is the voltage at point B? So the voltage at point B is going to be the voltage at point A minus whatever drops on the resistor. And whatever drops at the resistor, right? So we can symbolize that as the voltage at B is 12 volts minus VAB. And the voltage drop on the resistor can be easily calculated through Ohm's law because we have the resistor and we have the current that is flowing through it, right? And because we have this current source inserted here, the voltage across the resistor is not 12 volts, right? The voltage at point B is not 0 volts because the negative side of the ground is not connected directly to point B, but through a current source, okay? But this makes it fairly easy to know the voltage drop because we know that the current is 5 milliamps. So if we want to calculate the voltage drop on the resistor, that would be 1 kilo ohm times 5 milliamps, and that would be 5 volts. So we have 12 volts here at point A and 5 volts dropping on the resistor, and that leaves us with 7 volts over here, All right. Now, let's have a look at another example. Again, we have the same circuit as in the previous slide, only the current source, instead of being of 5 milliamps, is 20 milliamps. So we start the same as the previous problem. The voltage on point A is going to be 12 volts, right? Because it's set by this voltage source. The voltage on point B is going to be 12 volts minus whatever drops on the resistor, same as before. Only the voltage drop on the resistor now it's 1K, 1 kilo ohm times 20 milliamps. And that is 20 volts, okay? So we are dropping 20 volts on the resistor. So if we do 12 volts minus 20 volts, we end up with negative 8 volts on point B, okay? Now, some of you may be surprised a little bit by this result, by this negative voltage on point B, right? On all the circuits that we've worked with, all the voltages that we have in the circuit are somewhere in between the negative and the positive side of the supply. This is a little bit different, right? And we're going to see why in a little bit, okay? For now, the only thing I want you to focus on is how to solve the circuit, right? And you may end up with values, with negative values here, right? We'll see what that means in a few minutes. Let's consider this other circuit, right? As you can see, it's the same as before, only we move the current source from this side of the resistor to this side of the resistor. So we want to calculate the voltage at point A and the voltage at point B. The voltage at point A, same as before, is set by the voltage source, right? This is 0 volts or ground. And the voltage here is set by the voltage source at 12 volts. Now, the voltage at point B, it's going to be the current times the resistor, again, Ohm's law, right? And if we do 20 milliamps times 1 kilo ohm, we end up with 20 volts, right? So we have 20 volts dropping on this resistor again. So the voltage at point B, it's going to be the 0 that we have here because it's ground plus the 20 volts. And again, this may be catching your attention because the voltage at some point in the circuit is higher than the voltage from our voltage source. Okay, and we're going to see that in a minute, like I said. Let's try to combine the solutions for these circuits with what we saw at the beginning of this video, right? Devices that consume or supply power. So this is the first circuit we saw today in this video. And we have a 12 volt voltage source and then 1 kilo ohm resistor and then a 5 milliamp current source. And we solved this circuit and we ended up with a solution where the voltage at point B was positive, was greater than ground, right? And it was exactly 7 volts, if you remember. So the current through this voltage source is flowing like it will flow on a resistor, because this point B is at a higher voltage than ground, and current is flowing in this direction, top to bottom. Okay. So this current source is actually consuming power, okay? This is the second circuit we saw, where the voltage at point B is negative 8 volts, okay? So the voltage at point B is below ground, right? So this is, so when you look at it from this current source, this is positive and this is negative. And current is flowing from negative to positive, okay, from top to bottom, but the top is negative when reference to the bottom ground here. So current is flowing like in a voltage source, right? Therefore, this current source is actually supplying power to the circuit. And this is the last example we saw, right? Where the voltage at point B was 20 volts, right? So the voltage at point B is higher than the voltage at point A, right? So point A becomes the negative side and point B becomes the positive side. And current is flowing in the direction of the arrow. So from the negative to the positive side. So current flows like in a voltage source, and therefore this current source is supplying power to the circuit. So when we look at these two cases here, right, the case where we obtained a solution with a voltage below ground and another one with a voltage above the supply voltage, we reached to the conclusion that these two current sources are supplying power to the circuit. And that is why you are able to obtain voltages that are outside the limits of the supply voltage to the circuit, okay? So although we are not drawing it like that, the only way to get these two current sources to actually deliver 20 milliamps in these particular circuits is if these if there's something inside these current sources that is actually supplying power to the circuit. So the only way to actually physically build something like this is if you have energy stored here somehow, maybe with a battery or some other device. And typically this could be an inductor, and we're going to get there on the next video, right? So you may have a battery or an inductor or a capacitor or something like that that can store and deliver power to the circuit. And that's what's going to allow you to obtain voltages, negative voltages or voltages above your supply. This one here is a different situation, right? Because this is consuming power, so it could be replaced with something else, maybe a resistor here. So if you want to obtain the same current on this circuit, you could replace this 5 milliamps current source with a resistor, and whose value would be 7 volts, which is the voltage that you have on this node divided by the 5 milliamps. That will only work as 5 milliamp source for this circuit. If you change anything on this circuit, it's going to be a different current. But what I'm trying to say is this current source does not necessarily require a power source because it's not delivering power to the circuit. So this could be something as simple as a resistor or other device that is limiting the current to 5 milliamps. Okay, let's review what we saw in this video. Current sources are devices or circuits that force a set current through a branch. So if you have a current source, you know what the current on that branch is going to be. You do not know what the voltage is going to be across the source, but you can calculate that depending on the rest of the circuit. And the current sources can be supplying power to a circuit or consuming power from a circuit, depending on the voltage polarity. If it is supplying power to a circuit, they would have to be connected to a power to a 120 volt outlet or some other kind of external power source, maybe a battery or something like that, or maybe storing energy in the way of a battery or a capacitor or an inductor, which we will see in our next video. So that's all for this video. Thank you for watching, and stay tuned for a video on inductors coming up next. Thank you.